Yeah, hi guys, this is Vijay. So in today's session, we are going to talk about few topics. So we are going to talk about Apic architecture, okay? And we'll talk about Apic fabric discovery, and we'll do the deep dive overview of this Apic architecture. And this is very important in terms of for the interview point of view, as well as for deployment in the real infrastructure. Okay, so this is the major point here I'm going to talk about is like how the Epic behaves, how Epic architecture works, how the Epic really work in the with the ACI leaf and spine architecture. Okay, so let's take a look. We have this infrastructure. We have three Epic which are running in a cluster. So how you know that how many Epic nodes we require to form the cluster? We are minimum we should have the three physical Epic to form the cluster, and we have two spine switches and two leaf switches here. Okay, and Epic 1 and 2 is connecting to leaf 101, Epic 2, Epic 3 is connecting to 103 leaf. I have the setup, I can show you guys. So this is the Epic I have 101, 102. Epic 101 is having a leaf 101 having a 2 Epic, and leaf 102 having a leaf 3, 1 Epic. Okay, if I show that, yeah, this is the overall we have. And let's get started. So I'm going to talk about the first discovery. When you set configure the Apic act as a DSCP server for your leaf and spine. So there is a basic requirement for Apic configuration. You must visit my Apic initial configuration video, where like what is the mandatory, what is the prerequisite to bring up this Apic cluster, and these are the some process which Apic go through it. So if I walk through it, how Apic initialization work, let me walk through it first. So if I go here, so when you first time bring up the Apic will automatically have the LLDP running between leaf and spine and between the Apic and leaf. Through the LLDP, Apic will discover your switches, and on the Apic you can run this command to check that what is the LLDP interfaces which are discovering. After discovery, your DSCP configuration will be pushed. So from the Cisco Apic to the ACI leaf and spine switches, then Apic will push the ISIS underlay configuration between the leaf and spine. Then it will do the certificate validation, SSL certificate, and then you can check the DME log. So what these are some basic stuff. So I already have these basic things. So let me go and check so that I already have that ACI fabric up and running. So if I go here, so through the like how you can check the DSCP whether it's assigning the IP address or not. So let me give you the one command which you can use to check that what particular uh, how you can check that, how you can verify that how Epic is assigning the DSCP address to a leaf and spine switches, right? How you get to know that? So through the Epic DME log, data management log, you can verify that, okay, this is the Epic. This is the something which is, uh, this is how the Epic is assigning the IP address, okay? So let me give you the command. It's very hard to remember the command, to be honest, because the Epic is command line is strange. I would say it's not hard, but it's strange. You really do not need to remember that because everything is you can find in the Google Cisco official Google doc. Okay, so let me log into one of the Epic I have. So I have this. So I am using the virtual environment, not using the physical environment. So please avoid that any kind of. So the moment I put this command, if you'll see that, if I remove the mode, you will see that how Apic has assigned the IP address to multiple switches, multiple devices. If you see that these are the devices via this interface, bond interface, 1040/4 interface, which is the infra VLAN. So if I go and put the more here, which switches are getting more at which address? So if you see that here you can see that this is that I say there must be switch information. So let me I missed that command more. Let me put the command again. Something is wrong with this command. So I need to, I think, there's some space. Okay, so let me go to the below. So if you see that here should be like device name, which device is getting what address, all the things you can capture from here itself. Okay, so here you can see that DSCP acknowledgement, DSCP discovery, and there must be device name which reflect that okay this particular IP address is assigned to this particular leaf on spine switches. Okay, so where I can find acknowledgement. Sorry guys, I'm kind of this command should work fine because I tested this command is fine. Like this one, you can find out like which device has got what information. So I'm taking the DME log. What is the DME log? You can I will explain you that what exactly meaning of DME log. So DME log is data management logs. Engine logs, it means all the process of the Apic will be sitting over there where you can verify that. Anyways, this is the how you can check the log. Okay, like DSCP discovery, offer process, request process, acknowledgement process, all the things you can capture from here. Okay, from the DME log. So let's just start talk about the architecture here. Okay, how Leaf is fine, how Apic architecture works here. The major topic. So when you first time log in the Apic, you have multiple choices to handle your entire Apic. First is CLI, UI interface. Second is CLI. Third is web interface. And apart from these three, everything is API based. Okay, so if you have the experience with the Python SDK, if you have the object browser experience, you know that how it works. If you have the API tools you can definitely log into Apic and you can configure the entire Apic. So it's a very like kind of open space. If you know that CLI, if you are like network guy, you can use CLI and UI. If you are like DevOps guy, you can use web and object browser. If you are like developer, you can use Python SDK. If you are like don't know anything, always go ahead with the UI interface or CLI. So there is a flexibility, whether it's a technical or non-technical engineer, they can access the Epic and they can take a look the way they want in the format of they want, right? So object-based storage. So ACI works based on the managing object base, where you have the like hierarchical configuration, where you have the tenant, VRF, BD, EPG, access policy, all the things. Similar way in Cisco ACI, we have object hierarchy, where you have the root first. Like if you're getting the tenant, suppose all the tenant configuration will be under the root. Then if you're getting the VRF, then your uh, this VRF will be under the subroot configuration. Similar vice versa. So basically, it's kind of managing object tree based on the tree hierarchical object hierarchy. Your ACI configuration works. Okay. which I will explain in the next some session, where I will explain that how the API works with the Cisco ACI. So, for example, here we have here. So, if you go for the managing object infrastructure, we have tenant here. Okay. So, similar way, your kind of configuration works here. This is just part of the configuration. Okay, so how data management engine looks like while you configure the Apic, how Apic process your configuration, right? This is the deep inside of the Apic. So Apic is just a Linux based. Apic runs Cisco ACI. Apic runs on top of the Linux based OS. Okay, so when you purchase a box, Cisco gave you the X kernel in a Linux based OS. On top of that, you have the ACI. ACI image, ACI kernel image, right? And these are the some memories and object storage which Epic use for the ACI configuration. Okay, suppose we have DSCP. So as I said that DSCP act as a Epic act as a DSCP server for the entire fabric. The meaning is this DSCP Epic will act as DSCP. So the moment you assign the tab pool, so from tab pool, Epic will assign /32 loopback address to all the leaf and spine switches. Okay, how many loopback address assigned by the Epic? There are multiple. If I go and show you that how it looks like, so let me give you that. So if I go to here, if I show that how many loopback Epic assigned to the devices. So I show that here. So there are multiple, but there are few major loopback addresses which Epic assign. Okay, like first is a BTAP address, which is physical tap address. Second is a BPC tap address. Third is a FTAP. Fourth, five is a proxy tap. There are many more. So each, like here we have. So how this paired tap address been assigned? So we call that loopback one, loopback two, loopback three, like that. So first loopback zero will be used as the physical tap address, which will be used for all the routing and the VXLAN tunneling setup. If you go about the loopback 14 or sometime it give you loopback one or two, this will be used for the proxy group databasing between the leaf and spine switches. So when you first log into spine or leaf switches, so you have to check that how many loopbacks are created. It's not like there will be just one loopback address. There are going to be multiple loopback addresses associated on the interfaces. Okay. And loopback 13, 15, 17 with the anycast on spine switches. So some of the loopbacks will be only on the spine switches, some of the loopback only on the leaf switches. So this is how you differentiate that. Okay. So this is just the loopback journal information. You can even log into the, I check with that, ACI tag, FNB to read. If you see that I do have this tap address, right? So this tap address, unfortunately, I cannot log in due to the some these are the not physical devices, but these are the tap address. These are the physical tap address which been assigned via the APIC to the leaf and spine switches. This is a loopback 0. Likewise, we have loopback 1, loopback 13, loopback 14, likewise. Okay. So let's go and take look on this. So as I was saying that DSCP boot manager is the one which is responsible for assigning the DSCP address. So there is another table which is application director, which is responsible for the all the basic setup. If I go here, this is initial IP address allocation DSCP. Okay, and application director is responsible for IFC, which is application cluster information, health, heartbeat, expansions, ranking. All these features will be work under the appliance director. The reason I'm talking about DME interface or DME engine because when you try to troubleshoot the Apic, you should know how many application, how many engine or sub-engine types are running within the Apic database or within the Apic infrastructure, right? Third is a policy manager. So policy manager work is to it is for the like repository for the all the policies in the fabric, policy resolution such as distribution of policies to embedded policy elements. These things work on the policy manager. And fourth thing is that topology inventory. So when you have the AP, if you see that this is a topology, okay, and in the GUI interface you have this tab, topology tab. These tables will be maintained by the this particular engine, okay. And if you talk about the VM management, if you have any kind of VMware setup with the Apic Cisco ACI, all the configuration will be under the VM manager DME file, okay. If you have any kind of event fault, something like that, this all will be under the event manager. If you want to debug, diagnose, log, span, or any kind of tech support you needed, when you do that export tech support, all these things will be under debugger. In the, in the observer, you have the roll up variables, hardware states. These all the information will be there. In the reader, you have the API response data. So if I say that API response data, if I go here, inspector, this is the API response data. If I click somewhere here, it will give me the path. Okay. For example, look here. It's giving me like this one. If I click in the tenant, for example, let me give that for my example. Look here. Is what is saying that. Saying that it is monitoring my accounting data. You can say that. And it's saying that you are under tenant. Okay, and that all the tracking information will be under the reader, so you can capture all the data for security purpose. Because if you see that this reader also consume associated with the security data. So if suppose I'm clicking or changing anything in the infrastructure, all will be logged will be in the security. Okay. And the last one, not the least, is like security, which will be like for the RBAC, AAA, LDAP authentication, all will be done over it. Okay. In a deep overview, just give me a second. Yeah, this is done. Uh, this is the major like what Epic do on the Epic services. Like policy manager distribute the policy repository, responsible for definition and deployment of the policy-based configuration. So when you configure any kind of suppose VLAN you're creating through the Epic, suppose you're getting the routing or anything, this is the uh, kind of service which Epic use to push the configuration between the leaf and Epic and spine and Epic. Second is the topology manager. It maintains the up-to-date topology. Suppose you removed one switch, added another switch, or change the name, change the IP address. All the details will be managed by the topology manager. Third is observer. It's very useful. You can see that it's kind of maintain the operational state, health, performance, kind of dashboard. Okay, so if I show you that, what I'm meaning is dashboard here is, so let me go here this time. So this is the dashboard, right? This all the data will be maintained by the that repository. Okay, and let's talk about how the leaf and Epic communicate. When you first time bring up the process, when you configure the Epic for the ACI policies, how Epic react and how it interact with the leaf switches or spine switches. Okay, so this is the below one is the leaf architecture, and this is the Epic DME data management engine. So Ape is Cisco ACI leaf switches manage the object storage shared memory, where these all the services are going to run. Okay, so like suppose if we are pushing any configuration, it will use policy manager and it will push into the policy element as well as the OPEX element, because OPEX is the protocol which you use for the synchronization. Okay, for any third party or within the ACI sync. If we have any kind of like events or log, suppose one port is here in the leaf and that went down, how the Apic will get to know this port is down from this particular 101 leaf. This leaf has debugger which is associated with the debugger of the DMU. This is a database synchronization. Okay, it will immediately notify, okay, I have this problem. Apic will immediately uh, kind of update in the dashboard. So for example, if I go to Apic, this is the health. Okay, if suppose I down one interface or some line card module down or power cut happen, something like that, in this case Apic will, in this case your leaf switch will forward the message to Apic switch, Apic device, and Apic device will update in the database or dashboard, you can see that. Okay, and like atomic counter, blah blah, lot of things are observed here. So these are the some feature like intra-fabric messaging, which works based on the updates. So I hope you guys have better understanding now how Apic syncs with the leaf and spine switches. So they have database, they have object storage, they have DME engine, data management engine, which is responsible for the intercommunication, inter-device communication, or inter-fabric mesh communication. We call that IFM. Okay. IFM, what IFM handle here? So IFM stand for infra fabric messaging. It's a software layer, so that tries to deliver message between the various DME, like between the switch DME and the Apic DME. Okay, like suppose Apic is you configure anything, Apic DME will push to the leaf and spine DME. If anything happen in the leaf and spine, that leaf and spine switch DME will forward the message or alert to the Apic DME. Okay, and it's kind of like uh, uh kind of it maintain the how you can say that how this DME communicate, what kind of protocol they use, right? I'm saying that, okay, policy manager communicate to this and topology inventory communicate to that. But how we get to know that which protocol we use, because Apic is a physical set of physical device, and leaf and spine switches are set of physical devices, right? How you get to know that whether this particular uh, communication is working or not. Suppose you're having a problem, you have configured the Apic, but your Apic unable to push the configuration to leaf and spine. How you got to know that whether it's working or not, right? So this communication, this DME and DME. So in the DME, there are multiple processes like policy manager, debugger, or event manager, nginx, all these things will be here. So they form the TCP connection. They form the TCP connection. So and what TCP connection? They have different port number. They have different port number which they use. So what is the port number they use? Let me show you that. They use this port number. Suppose if you're having if you want to check the policy manager whether it's up and running or working or not, right? How you check that? So you just filter that this port number. So if I go here, if I net state TP, if you put the command, all all sort of like communication is here. TCP connection, you will see that they are forming with the leaf 3, leaf 4, spine 3.4, leaf 2, leaf 1. They have all the TCP connections, right? And there are some waiting. Suppose there is an issue with your devices and you want to check the policy manager. So what is the port? 12 to 12215, right? So let's go and grab that 12251, I think, right? Or 215. If I say that, look here, what is saying that this is mean this there is a communication between Apic 1, Apic 2 using this particular port number, policy manager. This is the policy manager. It means if this port currently being used to sync between the Apic nodes. We have three Apic nodes, right? Now it's such a topology 1, 2, 3, 1, 1. 1, 2, 3, 1, 1. Not the right port. 1, 2, 3, 1, 1. 3, 1. That's right. But something is not showing because maybe port is not built. It's checking the boot manager 12535 535. Look here, saying that this is the one. If I check the policy manager, for example, or policy manager, or not policy manager, let's check that a DSAP, right? 126695. 12695. So if I go directly 12695, there is a like this is a virtual environment. It sometime it won't give you the exact output. However, you can still like get some of that. It's showing that should be by root. This command should be run by the root admin. So root admin only tech support can get the access for the Epic root. Okay, few other services you cannot. Epic does not allow you to take the control or do the modification, right? So if I go to the like elements 12119, I'm sure that 119. So in the element, it's showing that it is establishing with the spine 3 currently active session. Waiting session is not showing. Okay, currently active session. So you can check that this is the how the like ports or the data management engine talk to each other. Okay, and let's talk about the Epic cluster now. How Epic cluster forms and builds here. So Epic cluster formation and heartbeats. All the epics are active. Okay, so how epics form with each other, right? How they interact with each other without a directly connection, because we directly connect to the spine leaf switches, right? We do not connect epic to epic interfaces. So epic appliance discover each other via the ISIS LLDP protocols. Okay, so suppose you bring up this leaf, okay, and you forward your traffic to this. And if the moment Apic discover here, Apic will automatically map. If the Apic is connected to the same leaf, it will automatically say, okay, I have this Apic cluster, this serial number also. The moment Apic will see that, okay, serial number registered in my database. The moment it try to register, it will say that, okay, this is the Apic node, another Apic node, and it will verify the health of the Apic, health of the Apic. The moment it say that okay, health is fine, configuration is same, what is mine, this form the cluster with this Apic. Okay, so this change the 3 unicast heartbeat per second Apic sent. Okay, so that something happen if they are dialect, if they are within the switch, they can send like this. If they are between the switch, they send like this, like this. Apic send the heartbeat. Okay, heartbeat are exchanged in inbound interface. Inbound means they are through the leaf and spine switches. Outbound means they are exchanging from outside interface, like this. Okay, and each epic and all nodes in a fabric maintain the appliance vector with the information about which epic is active normally or 3. So this is the basic prerequisite. As I said, that AP can be 3, 5, or 7, or 9, till ID can be 32. But this is the AP counter based on your requirement. You can use the or select the Cisco Epic cluster. Suppose you have 200 devices, or you have 50 devices. Based on your requirement, you can check that. And there is a like Cisco Epic matrix in the Cisco doc, where you can check that if you have 200 devices, how many Epic you should use. If you have 400 Epic devices, leaf and spine devices, how many Epic you should use. This is the journal like recommendation from Cisco, which you can check that. If how you can check that, you can check that here. So controller, you can check how many epics are up and running. Details, I think there is an issue with this environment. There is another way, like, so if epic, like ACI, so sorry, ACI tag RV read, or AB read, you can check the number of the nodes here, or AB read, I would say. From this command, you can check the how many epic nodes are here. We have appliance 1, 2, 3 right here. So you can check that what is the TAP address has been configured, what is the out of band IP address has been configured, what is the fabric name, and all the things will be here. What is the local ID? If you see that here, all the things and is being up. You can check from here and make sure that if suppose your TAP address is different from this to this, a peak will not form the cluster within the same fabric. Okay, and if it is different fabric, definitely it will consider for few things. If you suppose you have the wrong fabric name, if they are in the same fabric, they will not join. Okay, this is the kind of prerequisite which epic needs to be matched, right? Let's go for next. How the epic share the or form the replica. How epic database maintained, right? This is a very famous question. How epic database maintained? Because there are three epic. The first question is, do these epics work as a active, or do they work as a active standby? How do they work? And I would say that all the epics will work as a active based on their services. Okay. For example, meaning there are service shared and replica. Okay. Services means suppose you have topology maintenance DME. So in the last, I have explained that like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 services which runs. Okay. When you run the 10 services, you have different services. To each services select by default. For example, you have service 1. In the shared table, shared 1, this will become the your leader, and epic 2 become the follower, epic 3 become follower. For service 3, this become a leader, this become a followers, this become a followers. So it's kind of distributing your loads among the available clusters. So ACI service, DME, data management engine, are organized in a database. DME are process owning the MO or property of managing object. Okay, shared is a subnets in a database. Each MO is a part of the shared. These are the managing object. Okay, each shared, for each shared there will be the leader and 2 followers. If we have 3 cluster node, if we have 5 cluster node, so 1 will be leader, 4 will be followers. So what is the meaning of followers and the leader? So if suppose we are pushing the VLAN from the policy manager, and for policy manager, Apic 3 is a leader. So always the moment you configure the any kind of configuration from Apic, irrespective where you logged in, that configuration will be pushed from the Apic 3 and it will sync with the Apic 1 and 2 followers. So always your configuration will be maintained by the Apic leader, you can say that, in the database. Okay, to get the more example here. So Apic database, like all nodes in a fabric, know about each Apic is a leader for each shared, and which replicas are followers. So each Apic, they already have the information about the database. It's not like you have to tell anything. This is the by default nature of the Apic. Okay. For example, we have taken here example two, tenant configuration and VMM configuration. For example, okay. If we take that, so for tenant, this is the leader. Okay. These are the followers. Apic 1 is the leader, Apic 2 is the followers. And here for tenant, for different configuration, if you say that, let's give me a second. So for tenant 1, this is the leader, this is the followers. Okay. For the VMM configuration, this is the leader, these are the followers. For the shared 3, which is for example, you say firewall configuration, this will be the leader, this is the followers. So each your Apic will acting as a active, and it's not something which is having this will create the issue. No, you can log in any Apic, you can log in any Apic, you can configure anything. They will automatically sync. Suppose, for example, and this is the Apic 2 is a leader for the VMM configuration, and you logged into Apic 3 and trying to configure a VMM domain. It will automatically sync with the Apic 2 and Apic 1, okay, saying that I'm pushing this configuration, but make sure that you are in the sync because you are the leader, not I'm not the leader. Okay, this is how Apic synchronization works. Okay, this is the more like replica how it works. So always leader will push the configuration. Always leader will push the configuration. For example, this is the shared. So any configuration between leaf and Apic, leader will receive the traffic and leader will share that information to followers. This is something by default happen. You do not need to configure anything here. Okay. And for example, if suppose one Apic is down, for example, if one Apic is down, how the another Apic will take over the place of the down Apic. There going to be the election. There is going to be a election for majority quantum required. So if, for example, uh, okay, so this happened based on the majority minority election. Okay, so any of the, suppose if this Apic down, you have three Apic, right? Apic 1 to 3. If Apic 1 is down, Apic 2, Apic 3, any of the Apic will become the leader based on their internal calculation. Why this two Apic become the leader? Because there is majority minority concept. If minority is failed, majority will become the leader. It means suppose we have one Apic which is only cluster down, but this Apic up and running is still fine. It means Apic will automatically say that, okay, we are the majority. I'm going to take over all the ownership which I was followers from the Apic 1. Okay, and this case Apic 2 and 3 will take over the Apic 1. So the disadvantage is, if even if you try to log into Apic 1 you will not be able to log in. You have to reset the password, you have to reset the Apic cluster. For here, all the operations you can do from here. Here you will followers leader means read write operation you can get, and followers means only read operations you can get. Okay, and this is another like how the configuration works. So leader will always push the configuration, and this is again same like if uh, shared multiple shared fail, how it works. And suppose what if three Epic have not yet installed? You have just one Epic. Okay, you have just one Epic. How the things going to work here for you? For example, okay. So when you start the fabric with a single Epic, when you have single Epic, when you start that fabric, sets are not in a minority because the cluster is not yet formed. The majority minority cluster distribution all will happen when you have more than one epic in the fabric. In question is, can we have two epic cluster? No. This is something Epic has Cisco has designed. You can have the odd number of the Epic in the cluster. You cannot have even number like 1, 3, 5, 7, 9. So you cannot have like 1, 2, 4, 6, 8, no, or 10. You cannot have that. There is a concept for standby, which you can have as a standby like 3 plus 1, total 4, and this will become the standby. It means this will not be in a use. So is I will even calculate it as 3. Okay. So so this is something if you have one Epic, this is something a special case designed to support zero touch provisioning. And this is only one, there going to be one replica. It means if for each and every services, one master. It means one shared, one leader for each and every services. And there is no backup or anything like that. Okay. Epic will create new replica as soon as a new Epic is added. So suppose you have one Epic just for provisioning, and after provisioning, you found that okay, there is another Epic also, or there is another Epic also. Epic will automatically sync that configuration, and it will create the replica over here. It will start creating the replica. Okay, and this explains why when installing the Epic Fabric is the first time you operate the Fabric even with the single Epic. So question is, can we operate ACI with a single epic? Obviously, but exceptional case while doing the fabric discovery, you can have it. For the long term, it's not recommended to do that. Suppose, and there is a limited support. And suppose if you are running the one epic, like 3 to 4 leaf and spine, you can connect. If you have more than 3 or 5 epic, you can have your fabric capability will be enhanced. It's going to be the 200 leaf and spine, something like that. Okay, let's talk about the epic management trees. Just give me a second. Yes. So Epic cluster sharing. Okay. Epic management tree is divided into the database unit, call it the shared, to allow the load balancing and scale the solutions. That's the whole purpose of sharing the database among the pre or among the cluster nodes. Okay, shared assigned to appliance by the static shared layout. Okay, each destination node is mapped to shared number from 0 to 31, which I will show in the next slide. Data access together is put in the same shared, all data for tenant to one particular shared. So just like a like leader will have all the majority of the control over the data. So user sees the combined MIT on the Apic, on any Apic. For example, as I said that if the moment you log in the Apic, if you will not able to identify which one is the primary, which one is secondary, because each and every individual Apics are in a cluster, they will act as a single identity for you. But internally in database, they are going to be the multiple shared and replicas will be created. Okay. So this is how the like shared replica works. When you create, for example, tenant, suppose you created the three tenant, for example, right? So tenant one can be for tenant one, master can be your Epic one. For tenant two, it can be master Epic three, like this example, and other can be followers. So it is kind of sharing the load among the Epic. Suppose you have 1,000 VRF, right? 1,000 VRF, and you push all the configuration in the one Epic, right? It's not good, right? Because when your Epic is down, it can happen like your database something disrupted, something happened, right? So it's better to distribute your MITs among the multiple nodes, right? This is why Epic is much more flexible, and if you are distributing this a kind of behavior, or if Epic is distributing this kind of database among the multiple, it means you are getting the scalability as well, you are getting the safety in the infrastructure, right? If you are very unlucky, then in the case, of course, no one can save you, entire your fabric is down, then it's a different case, right? But otherwise, Cisco has really designed Epic clusters such a way to scale your solution as well as give you the better performance, and along with the high availability. Okay. And what is the split brain? Suppose I showed you that one Epic failed, what will happen? Okay. If one Epic failed, what will happen? If two Epic fail, what going to happen? Okay. That's a different set of scenario here. So if like BPC is split brain, so suppose you have two VPC member one or two, right? Member one or two. If this both peer link is down, this both become active, right? They will treat as a individual devices. They will not participate in a VPC. Similarly, if replica is not connected to any other replica, it, it said that it's a minority. Okay, no write request allowed in a minority to avoid issue in a merging the configuration, merging the vCenter update, merging the switch and configuration. So if you have three Epic, and out of three, two is down, one is there, one will be active. These two will not allow you to configure the configuration, or not allow to perform any kind of task in that. So in the minority, like suppose if you have three Epic, two is down. So minority Epic, here we are minority. We have all all going to be minority. All will have the like read only access. Irrespective of cluster size, two Epic down or disconnected will cause the some share to be in a minority. Okay, and irrespective of cluster size, if three Epic is down in case of five cluster, it will cause info loss in a database. So this is something is concerning, to be honest, for me, because Cisco designed Epic to manage the like cluster, but if you have the very big outage in the infrastructure, a majority of the devices are down. In this case, you will definitely have some like a data loss for sure. Okay, why we need minimum 3 AP? That's a question, right? So since leader election in the distributed, we need majority of replica to agree to the leader. Suppose you have two person in the same room, right? And if election happen, no one will win, right? If we have more than 2%, if we put the 3% in the room, and if do the election, and there is a highly chance one there is a highly chance majority will win the election, right? Similar way in Cisco AP, this is why when we have three AP not plus. It means if any election happen, majority will win. This is simple, okay? And let's take that walkthrough on that. Epic one, obviously no fault. If you have single epic, there is obviously there is no fault tolerance for you. It means if one down, entire epic will be down. Okay, and suppose you have two epic and right, I mean unavailability with a single failure can be recovered if epic is replaced. Epic 3, if one loss, other two become the leader and continue the rides. Suppose if one epic down, no data loss. If epic two epic down, the write unavailability with a single epic failure can be recovered. It means if two epic is down, you cannot do any configuration for some parts from one epic. Okay, and if you have two epic down, then like if one epic is down out of three, then still all will be up and running. You will have some issue with the no write for the shared, which are in a minority, but still you can have the read only access. Let's take a deep look into the cluster. So which I was talking about, like health sequence, like first we'll check the IP connectivity, heartbeat exchange over the in-band. Then step two is appliance vector check. If anything happened to the epic, these are the three things you first need to check that. Okay. Step three is replica vector check, all shared of the DB to be healthy. Okay, how you check that heartbeat, all the services and size and all. Okay, so there is multiple way you can check. So first is UI or from the CLI, both you can check that. So if I go here and check here, if I go, let's begin. See, if you check there is a operational health. If any of the heartbeat is down, they are not able to communicate through the in-one interface, this epic will become unavailable. There you will see that issue with the epic. So if I go here, epic 1, if I say cluster senior node, you will see that 3. Target size is 3. This is the fabric name, this is the fabric ID. You will see that 3 nodes are here. And failover is idle. It means there is no failover. SSL is fine. Health is totally full and fit here. So these are the like things which first you check when you login Apic. Okay. Second thing is how you can check the controller. So as I was running the controller command is not working for me due to some not sure issue uh, with the virtual environment, maybe. Uh, like, go here, set store, controller. There is error. It means this is a virtual environment. So I don't think we can run this command here. Not sure. But the moment you run this command, you will get that all the health, just like we checked here, the same details you will get from the CLI. This run this command. Okay. And step one is like, uh, so how the Apic cluster form the like these are the few things. And three is like how you can verify the interface IP connectivity. So if config is fine, and if suppose your Apic is unable to sync with another Apic, you can just log in the Apic and you can run the command, you can run the ping, right? Apic 1 to 2. Like if config, just like the Linux based command, you can check that which interface you use for what. This interface is for Apic interface, management interface, and this interface Apic 2 E3 interface, which is being used for different purpose. And this is the interface which is in-band, kind of it used as an in-band for internal Apic cluster. So if I ping this IP address, ping 10.0, sorry, 10.0.0.1 Apic 1, ping is not working. The reason is here Epic does not have any kind of, this is a virtual environment, right? So I don't think Epic will able to ping anything. Right, yeah, not permission. So this is how you can verify it, right? You can just ping between the Epic nodes, Epic 1, 2, 3, and you can verify that, okay, this is how the Epic reachability is there, okay? And then thing is, these are the three major points, like a fabric node vector, like appliance vector, replica vector. What is the meaning of it? So this is fabric appliance vector means to check that how many nodes, what is the address, basically the infrastructure information. If I say here ACI diag F and V read, fabric node vector read, it will give you that leaf and spine information. It will give you that leaf and spine information. If you will go and check that AB read, it give you that vector of the Apic and their IP address state. Okay, so like I showed you earlier, so instead of FNB, AB read, it will give you all three Apic health and details. Look here. Okay, and if you run that RV read, vectors give you that who is the leader and who is the followers. Who is the leader, who is the followers. Let me give you that. RV read, but I'm not specifying any services to check that which is the leader, which is the followers. So if I put that, I'm not very confident. I have to specify that services. For example, in a like RV vector, uh, in RV vector, you check that details like uh, suppose you want to check the policy manager, right? So you check that policy manager through the ID. So there is a like way to check that each and every services. We have 49 replicas. We have 49 services running here. Sorry, this is a 49. So we'll see the shared. These are the numbers which you have to, if you want to check this, for example, let me give you that. Like how you check that which one is the leader, which one is the followers. Okay. So here is RB read. So if I go and not, this is the healthy, this is the non-healthy. So if I go and check that, for example, this is the shared, okay? S means shared, R means replica. If suppose I check that shared replica anything, you can say that, right? Or well, so if there is example like state 6 where Epic is running, so 912 I'm going to select, check that what is the 912. So this is the example, okay? Shared which for the each leader. So shared 6 means policy manager. So suppose you have like uh, let me copy this and paste that. I'm going to show that which Epic is leader for which particular services. Okay. So if I go here 6, it will give you that this particular Epic is leader for how many services. Okay. This is the very good way, like policy manager with the shared 147. These are the these are the some replica details. For these replicas, this APIC is a leader. This APIC is a leader. So if you look here, this is the leader. Just give me a second. So this is how you check that for the any particular services. So for example, I have checked for this service, this service, which is the policy manager shared. This is the replica. So replica, we have many replicas. These are the replica 1, 2, 4, 5. This is the replica. And the shared is a, we have 6 for check for the policy manager. This is the policy manager. Similar way, if you check for the some other like other shared apart from policy manager, you can definitely check that. So these are the some list here. Okay, this is the policy manager. If you want to check for the topology, you have to put 9. If you want to check for the VMM domain, if you have to check something else. If I pick here and select 9 for the topology, who is the leader? So if I'm going to say for policy manager, there is a different replica. This is very important when you have any kind of uh, this is the, you can check that for this topology manager, for these replicas we are the leader. For different these are the few replicas out of 45. These are the some replicas for which we are the leader. Okay, and this is very good example, to be honest, and you can just do the some due diligence on this. And to check that all the three, this is the command, this is the new command which has been introduced in the 4.2 Apic. You can directly type that AP read and see that health of all three nodes uh, of the cluster. If suppose you have 5 nodes or 6 nodes, you can check from this command. Okay, so you can just suppose you have the version issue, something like that. You can check from this command AP read. It will give you that all the details, like what is the active, and do we have the like chassis number, serial number, port ID, stack details, route address, out of band management address, what is the current version is running. All the details you can pick from here, which is very useful command, which is only supported after 4.2 version. I'm running 25.2 version. That's the reason I'm able to see that. Okay. And yeah, this is the like uh, verification command, and this is how, this is the major kind of verification. When you know that uh, how to check that database services, that time you must be kind of uh, at least you should have the awareness for sure, like all the epics details. If suppose having some database issue or some outage happened due to some epic glitch, in this case you can always troubleshoot epic if you know that how to troubleshoot the DME database management engine. Okay, and this is if suppose you are replacing the epic. Suppose you have a 3 epic, one of the epic is down, you want to bring another epic, right? How you do that? So need to remove the existing epic ID from the to the chassis associated, decommission the existing epic. Okay, and disconnect the epic from the fabric, disconnect the disconnect the epic or replace the epic which is new epic, and commission the new epic. And it's recommended to boot up Apic after it connected to the fabric. So it's very much simple. You just suppose you have 3 AP. Let's go step by step. 3 AP. If this was down and you plan to purchase a new one, in this case, you just disconnect this Apic, remove the configuration from the chassis, and especially the if there is any in the database, and you bring up the new Apic. You just configure the same exact out of band address, exact same configuration which we had in a old Apic. You just bring up those and connect your Apic to the physical device. Physical device will automatically form the cluster. You do not need to worry about it. Okay. And this is the to check the replica vector. If some device, some services DME process are not healthy, in case, and check the process name means ACI tag command, and check the process is running on each epic like uh, PSEF. Let me give you command this. So check that if any service is having a issue, it will automatically give you that logs here. Okay, it will give you that state logs here. And if you're having any kind of issue, you will see that logs file here. And you can extract the log file from here to your desktop for the troubleshooting purpose. And you have to put the so code if something glitch happen on the Epic, and device will automatically generate the code file for you. So as of now, nothing is happened. Suppose Epic 2 is down or Epic 1 rebooted automatically. So Epic 1 will or Epic 2 will automatically generate the core file. And sometime core file doesn't generate by the Epic for some reason. If something kernel level effect is happening, or kernel level impact has been done, in this case core file you will not see that. Then there is only kind of no way to troubleshoot manually. You have to do it one by one through the command line. Okay. Okay, this is the how you can check that, and I would highly recommend you guys to check that like service details, especially the this one, a list of the services and list of the replicas. These are the services which is ACI runs, and each services has different meanings. Okay, you will see that verify that how many DME services are running, what the meaning of it. Let me show you that in an early slide. I've showed you this one, right? Then how you can verify that whether this is running fine or not, and if running fine, what are the details from where you can find the details, right? So you go to the Epic and type this command psef grep services, and you can check that. Look here, these services. So you can see that VMM, page manager, reader, observer, and stream, real read, or off flex, event manager, policy manager, all the option. But if you see that root, admin, if IFC, it means these file you can check through the root, this through the admin you can check that services, and this is the file we can check from any user. It gave you that what exactly level of access you need from the Epic in terms of getting that information. So this is how you check this DME, data management engine, all services. Suppose you're having a issue with the topology. Epic is not showing right topology. Which file you want to troubleshoot? You can check that topology manager, a latest one. There are multiple. Let's suppose 5 minute back, 4 minute back. You can check that latest one, and you can check that all the logs inside that. Okay, this is how the verification can be done for your database. Okay. All right. So, and this is the again check like uh, if you want to really check that core of the Epic files like policy manager, details. This is the command show code, and then you grab that from the Epic node 1 something, and you can get that all the like files from the device. And what happened when DME crashed? Like I was talking about, what happened if DME case? If DME crash in only the leader replica, the other replica election, or it automatically elect the leader. If crash is only followers, replica will not impact. Process is restarted or recover from the its SQL DB and catch up from the neighbor. Okay, when DME crash multiple times, what happens? It means core when your Epic crash multiple times, core crash multiple times. After X number of attempts to restart the process is left down. It means you will lose the data. If other replicas are up, they will continue to work. Otherwise, no services will be up and running. It means entire Epic will be down. Okay. And cluster faulty when Epic services is down. So this is how you can check that, like based on the details, based on the database. If you have database corrupt database, you will get that this error. If you have like issue with the health, you will kind of uh, it's kind of you are eventually losing the your cluster if you see that this kind of error. Okay, like this one. If you find that any kind of fault, the node 2 disconnected from node 1, so you will see that like this. So all the things can be captured from the Epic UI and CLI both. Okay. So if you see the ACI die cluster, which is not running command. So if I ACI die cluster, ACI die cluster admin, I don't think I do have, but let me try. Oh, perfect. This is the serial number, it's running, and it's a virtual Epic, it's saying that. So just to verify that, but I don't have the physical environment, so I will not be able to see that how many kind of replicas are running and how many shared or shared details or kind of services are running. I think I will not be able to, if I'm not wrong. Yeah, I will not be able to capture that. This is possible when you have the like uh, physical environment and that is running a version of 4.2 or above. Okay, and this is the summary of the cluster. Heartbeat goes down for invent. Check the IP connectivity. If every read is matched, check that fabric name, UUID, replication vector are fine. So these are the some basic like tips which you can use for the configuration. And best practices: take the periodic snapshot when you have the Epic and export the ACI fabric configuration periodically. No Epic reload if cluster is not fully fit. Do not attempt to recover by yourself. Sometime is fine, sometime is not fine based on the criticality of the health. Okay. And what if all three Epic goes down? This is the scenario. And the traffic forward continue for the new and existing session. Leaves are completely self-sufficient when it comes to the traffic forwarding and policy enforcement. As I mentioned that Apic is not control plane or data plane. It's just a policy controller. Even if anything is down, nothing will impact the traffic of the leaf and spine. Few things definitely will be impacted because VMM, when you're configuring the vCenter or VMM, VMware concept, you will not be able to do the vMotion based on the your kind of resolution. Depends on the deployment. And if the you have the snapshot, definitely anyone can recover, not only Cisco, but anyone can recover it, right? And the cluster speed recover through the OOB. This is possible, but I'm going to stop today here. and we'll capture next session for the OB like configuration. Our OB we'll cover the OB part of the entire why only Epic, but rather I will cover to the entire fabric. Thank you so much for watching.